Right, I think I will start now. All right. Okay, so welcome everyone to this first session by Enigma for simulation and design of robots. I think in the last session I had, which was in person and online, I had kind of communicated why simulation is really important. But in this session, we are not going to really be talking about that. Instead, we'll directly jump into the VBots simulator and get started on a couple of simple simulations and give it a go. Okay? So let me start sharing my screen. Can you see my screen? Hello? Yeah, you can see my screen, right? Let me just put the chat up here. Yeah. So I'm going to launch VBots. And let's create a new world. So the first thing you want to do is you want to open a new project or a new world. So for projects, probably a wizard, new project directory. Okay. Also, this is being recorded. Hang on, let me check if this is being recorded properly. Yeah, by and large. For some reason, Zoom, the recording option is disabled, so I am recording it on my laptop directly. Okay. So, new project directory. Yeah. So let's make a new folder and let's just call it example project. Okay. And let's just start with the today's so there's nothing here yet, obviously, but if I open up my file explorer, then in our example project there are these folders. So worlds is where the example which we are working on now, that's where this will be kept. Controllers will be the code for the robots. And then there are other folders. Protos are basically built-ins, some fancy stuff. Libraries if you wish to import anything else. Plugins if you wish to mess with the physics. But otherwise, let's just get back to the world. So the first thing you want to do is probably you want to, let's get rid of this first and just add what should we add first? Let's add, so if I'm going too fast, just let me know, okay? Because like a lot of this is muscle memory to me at this point. So what I did was I first clicked here, then this plus is where you can add new objects. Okay, you'll be using this a lot. So plus, proto nodes are basically imports from VBots. Okay, you can there are a bunch of default objects available. So I've added a background. On another note, you should always save very regularly. Okay, so to save, Control Shift S. Beats me why they didn't just go with Control S, but that's life. And let's add a light as well. So objects, and we need a floor because our robots are going to be resting on the floor, right? So floors, rectangle arena. And to rotate your view, just left click and move. To pan, right click and move. So this is left click and moving, this is right click and moving. It's a recording already. It's a recording in OBS Studio instead of on Zoom. Okay, so that's orbit and pan. And if you use your mouse wheel, it'll rotate like this. Don't really need it, but sometimes you do. So okay, Control Z that. So these three controls here are to move the object. Click on the control and you can move the object. Control Z, Control Shift S. And there's some other stuff which is useful. So view, optional rendering, show coordinate system. So it shows this axes here, which is always pretty handy. But this rectangle arena is pretty small, so let's first make it bigger. Let's floor size, let's make it 10 meters by 10 meters. Right now, that is better. This is a reasonable sized room for us to work in. Okay, so now this is well and good, but we want to explore more, right? Let's see what else we have here. So base nodes, robot, because we want to build robots here, so naturally. And to this robot, now we have to start adding things, because right now this robot isn't actually anything very special. Okay, it's just a base node. This is, so basically the idea is you add stuff to this to make the full robot. You need a chassis, you need some motors, you need some joints, you need some other links. So let's get started. I think it will become clearer once I start showing you. So the main fields here, translation and rotation, are basically the position. So translation is XYZ in terms of this coordinate frame of reference here. Rotation is basically you choose an axis and you choose an angle. Scale is fine. Children, I'll explain in a moment. Name is also fine. Contact material is to do with friction. That, ignore this. So mainly what you will work with are children, bounding object, physics, and controller. Okay. So now if you wish to add geometry, first let's add a shape. So by the way, before I get lost in this, you should have a look at the Weebot's documentation, because that is really good. They have documentation, there's a user guide, and there's a reference manual. So of course the version is different. This is for R2022A. I'm still stuck all the way back in R2019, but yeah, you get installing, building, getting started, introduction. Starting VBots, the UI looks a little different from mine because I've used a dark skin, but otherwise it's pretty much the same. Yeah, the scene tree is what I'm trying to describe to you now. This is the way everything is structured in here. And if you go to the documentation, to the API, there is this node chart, and there's a lot of concepts from Oops over here, a little bit of it. So this is like, for example, you have joint. From joint you have hinge joint. Derived from that you have hinge 2 joint and ball joint, and from joint itself you have slider joint. And from solid you have all kinds of things which are derived, like track, charger, robot. So by derived I mean like in the Oops sense, like inheritance. So robot, if you go to robot, you see derived from solid. So all the most of the fields which are there in the solid node are there in the robot node. Are you following me so far? So we've added this robot node. It has a lot of properties in common with the solid node, except for the fact that you can add a controller and you can add joints and do all kinds of stuff with it. So getting back to it, let's add in, no, let's not add appearance yet. Let's add the geometry. So let's add a box, and you can see a tiny box has appeared over there. Let's move the robot up a bit. And there are other geometries available. I can just right click, delete, and geometry. There's box, capsule, cone, cylinder. This is weird. These are all, sphere is okay, but let's go with cylinder for now. I'll explain why in a moment. So we go with cylinder. You can change the height. Let me zoom in. Scroll wheel to zoom, by the way, but okay, it doesn't look very cylindrical. That's because we've not defined the appearance yet. So let's, the proto nodes in appearances, there's a lot of things you have. You have asphalt. These are just for the appearance, not for the physics of it. It's just a JPEG that is, you know, put all around. It's nothing to do with the physical properties. It's just for the appearance's sake. So let's go with painted wood. And here we have some, we can change the color of it. Oh, let's make it blue to contrast with the, fine. Save regularly, okay? You can, this button also helps you save. I just saved from the keyboard, and I said I wanted to change things up. So let's make it 5 centimeters tall, and let's make it 20 centimeters wide, so radius of 0.1. And now here's something you can do. This child shape here is only for the visual properties. It's not for the physics. Okay? If you want to put it into the physics, you have to, for example, collisions. This will not collide with anything. This will not be affected by gravity or by any other forces. For that, you need to set the bounding object and the physics. So for that, let's first def this. This is like, this shape can be thought of as a variable in some sense. So just def it. I'll give it a name. Def is basically a field which allows you to give a name to anything in this way. So let me call it chassis shape, and then I add this to the bounding object as use. So this is like def and use. So okay, no controller yet. Now this will collide, but I have not yet added physics to this. So by this physics node here is where all the physical properties come in. So now here you can see density, mass, if you wish to change the center of mass or the inertial properties, anything else you wish to do, all that you can modify here. And now let's just see what happens if I play the simulation. This is a paused, so you have to play the simulation and see what happens. It falls down. It bounces a bit in a slightly awkward way. And now I should mention one thing. This world info node, you might want to mess with a few things here. So basic time step and FPS and optimal thread count. These three things here. So basic time step is how much into the future. How do I explain this properly? So basically, physics is continuous in nature, right? But computers and their entire logic is very discrete in nature. So it cannot compute the physics in a continuous way. It has to do it step by step in discrete time steps. So what is the time difference between two steps of the simulation is this basic time step. So right now it is set to 32 milliseconds. So I will instead set it to 4 milliseconds. In fact, let's see if there's a better explanation in the VBot's reference manual. World info. There's title info, gravity, basic time step. So this is the main thing. Setting this field to a high value will make the simulation faster to run in terms of how much computing power it takes, but will decrease the accuracy and stability, especially for physics computations and collision detection. So you want a low value if you want more accuracy, but a high value if you want more speed. Okay. So I've set it to 4 and I want to change the FPS because while my system is powerful, it's not 60 FPS level powerful. And now let's see what happens. It's running a little slowly. Yeah, VBot sometimes takes a little bit of time to stabilize. And you can see the speed of the simulation here. This field right here. Sometimes it's a little unstable. So if it gets unstable, just save your work. Shut VBots. Open it again. Simple. Okay, now we've got this thing. So we've explored the physics a little bit. But this can't do anything, right? So now we need to give it joints and motors and position sensors and all of that. So let's do that. So just to recap, a robot, the main chassis of the robot is a shape which you will give as a child, and that same shape you will def it here and then you will use it as the bounding object. And then in the physics node, you can add the basic properties of this chassis, whether you want to change the density or the mass. Mass is equal to -1 basically means it will use the density. If you wish to instead use the mass value, you give the mass something like, I don't know. Let's make it a heavy robot. 1 kilo. See, warning. Both density and mass specified, the density will be ignored. So let's make the density -1. Okay. and that way basically whichever one is not -1, that one will be used. You can either specify the mass or you can specify the density, but not both. Right, so now let's get back to the main story, which is adding motors to this. So let's wait, let me click here. Let's add a joint, hinge joint. Hinge joint is basically any kind of rotational motion, okay? Single axis rotation, like our elbows, or like the rear wheels of a car. That would be a hinge joint. But where is this joint? We can't see it. So in order to make you see it, first let's view optional rendering, show joint axes. That will help us first. Before that, let's add the hinge joint parameters. That will help us modify all the position aspects of this joint. So position is basically the angle. Axis is the axis of this in terms of the coordinate reference. So we want the axis. Okay, this time it's okay. So here it is saying the axis is 1 is the vector in the direction of x-axis, because x component is 1 and y and z are 0, 0. That is fine. The anchor is the location. So this is the angle of the joint, this is the direction of the joint, and this is where is the joint located. That is the anchor. Now this is what I wish to change now. So I don't want the anchor to be dead center, at the center of the robot. Okay, this is with respect to the center, with the 0, with the origin of the robot. Not the center precisely, but the origin. And in this case, the shape which we gave is centered at the origin. So this is basically at that position. So now let's move it. I want to move it, let's say 0.2. Too much. Did you see this line here? It came suddenly. This is our axis of the joint basically. So now if I just decrease it, yeah, that's good enough. And now let's add devices and endpoints, because right now this joint is not connected to anything. There is no solid at the other end. One end of the joint is connected to this main chassis, the other end is not connected to anything. So let's do that now. So we add an endpoint which will be a solid. Okay, now this solid is also empty, there's nothing there yet. So let's first move this solid and let's add, now let's see the difference between solid and robot. So because if you go to the documentation, robot is derived from solid, right? So there is that relationship between them. Solid is basically the parent node of robot. So translation, rotation, scale, children, bounding object, physics seems similar. If you see robot, however, you have translation, rotation, children, you can add bounding object, physics, and then there is this controller and controller arguments, plus this supervisor, synchronization, battery, all these things. So now this solid, we want to give it some geometry. So let's do it in the same way as we did before. Add a shape, add, let's get fancy, rubber, something with rubber. And let's add geometry cylinder. No, that's not correct. I don't want it to be in that direction. I want it to be like a wheel. So let's change that, and that's too wide, so let's make it slightly thin, and also slightly so if I move this robot up a bit, let's how big should we make it? Let me make it 2.5 and 0.05. No, too much. 4.35. Perfect, by and large. Okay, so now we have one wheel, but only the appearance of it. So let's and let's actually I want to show you something before. So if I make this wheel just for the heck of it, now watch this. I have not given it a bounding object and I'm not given it a physics node. Okay, let's see what happens. See, this is why we need to add a bounding object and why we need to add a physics node. Because without these two things, it will only display it, but it will not actually collide with anything. So let's do that now. So wheel one shape. So let's add that. And let's add the physics so that it will have mass and density and all that. Now I save it, and now watch. Okay, that's weird. So VBots is not perfect, okay? Sometimes weird things are allowed to happen in this software. So if weird things happen, just pause, save, open again. There, weirdness gone. So this weirdness is only an issue when you add new geometry, okay? And that is typically only in the initial phase where you are building the robot. When you are programming the robot, you are never adding any new geometry. So we have the hinge joint, but we don't have a motor and we don't have a position sensor yet. So let's add those. Position sensor. This name is very important now. So let's call it left, or let's be consistent. Right. Which way is left? Which way is right? Yeah. Okay, right sensor. And let's add motor. Okay, right motor. Then now we have the things needed to start programming this one wheel. I want to put another wheel, but I am a little lazy. So I copy this, paste it, joint parameters. I make the anchor on the other side. of x, and I put the endpoint also on the other side, and there are two devices. I rename it to left motor and left sensor. Okay, so now we have pretty much everything we need to get started to 1 degree, right? The physics is in place. We have the motors, we have the sensors if we wish to do anything funny with that, and now we can get started with the programming part of this. So controller is where you will be putting the program. So let's create a new controller. I prefer Python. I do not know how to use the other languages API for VBots. I know the Python API for VBots. 2022-02-04 example controller. Okay. Now if you go to the folder controllers, you will see a folder and you will see a Python file over there. So let's open this with VS Code or any other editor. You know, I like VS Code. So let me zoom in so that you can see. So VBots does a lot of things for you. Okay, so like so let's remove some of the fluff. So basically the idea is whatever setup is there will come here after like line 6. Okay, all the setup code comes here and the main execution code comes here. Okay, this will run forever until the simulation is stopped. Okay, so now let's first we need to add in the motors and we need to give some command to the motors. Fine. So let's do that now. So let me open the VBots documentation because I always forget what the exact command is. So rotational motor, robot, left motor is equal to robot dot get, it should be get rotational motor or something like that. Okay, so now let's get, where is motor? There is a, so you need to get good at reading documentation in general, okay, because invariably we will forget the exact commands. So motor, no, it will be in robot only. So let's go back to the documentation of robot. So it should probably be get rotational motor left motor right motor is equal to robot dot get rotational motor right motor left sensor is equal to robot dot get position sensor left sensor. These are the names which we gave. Okay, let's just see if this worked so far. This will not do anything, but we can see if this causes any errors. So let's set the... Hello? Did someone unmute? Yeah, that's okay. Just if you want to say anything, you can unmute, okay? Because otherwise this will be very one-sided. So let's select the controller. And let's clear the console and let's start. So there are some clear issues here. So I think I should see what I have done here. Let's remove these for now. And so let me open my code because I always refer to my old code. So let's open etc etc etc. I got the robot time step. Get motor is the command and get position. Okay, I wasn't too far off. And it's motor and position sensor. Motor position sensor. Okay, get motor okay. Now let's see if this gives us any errors. Okay, all is well. Now what is the next thing we have to do to get this to work? We have to enable the position sensors, and now the documentation will help us. So let's go to motor in the documentation. So velocity control, because we don't want to set the position of this, we want to give it a velocity command. So motors can be used with velocity control. First, the position must be set to infinity, and the velocity we can set accordingly after that. And we can do force and torque control as well, but that's a bit advanced. So in Python, it is set position, set velocity. So let's do that now. Let's just left motor dot set velocity 0, right motor dot set velocity 0, left motor dot set position float inf, right motor dot set position float inf left motor dot set velocity 1, or okay, let's not set such a low value, let's set it to 5 radians per second. Right motor dot set velocity 5. Okay, and this is still empty because we just have to do this once. Let's see if this works now. It started moving, but the simulation is getting a bit wonky. You can see that it is really fluctuating. This happens sometimes when you make changes to the controller, not the code of the controller, the name of the controller itself. So let me just close, open. So now it's moving forward. Great, but we don't want the robot to just move forward, right? We want to do something else with it. This is not quite there yet.
Why do we have to set velocity as 0 at the beginning before setting position?
That's an excellent question. So if I don't set the velocity 0 and I set the position as infinity, watch what happens. Here now nothing much happens, but if I've seen weird things happen, okay? In the sense, if I had not set the velocity as anything and I just set the position as infinity, okay, in this case it's not doing anything bad, but I've seen if your velocity you give a very high option, it will literally try to spin forever and ever.
Okay.
It's just a safety thing, okay? It's just so that we don't make any critical mistakes. But now we want to go beyond. So now let's look at the keyboard node, which is something very interesting, which will enable us to do a little more with this. So there's a keyboard node. Get keyboard of the robot class. So let's get keyboard, and let's get a keyboard out here. Keyboard is equal to robot dot get keyboard. So let's go back to robot and just check out what is there regarding the keyboard. Robot get okay, they basically it's like this only. So get keyboard is here. You don't have to give anything else to it, it'll just give you the keyboard. Okay, so let's go back here, get keyboard. Let's see what we can do with the keyboard now. You have to first enable it. Keyboard enable sampling period. So this is a common theme with most of the sensors in VBots. Okay, you need to enable them with some sampling period, and typically the sampling period is just this time step here. Okay, so keyboard dot enable time step. Okay, and now keyboard.getKey is the function we need. So this documentation is very good. Okay, you should be good at reading this. So get key function. So first key will only be available after the first sampling period elapsed. After that, values can be read by calling the keyboard get key function. The returned value, if non-negative, is a key code corresponding to a key currently pressed. Fine. So let's try this. Get key. Key is equal to keyboard dot get key. Print key, just to see what is going on. So now if I clear the console, I'm typing, okay? I pressed A and it's 65. If I'm not pressing anything, it is null. Anyone remembers what significance 65 has? Yes, sir. Correct. So now we have a way of reading the keyboard. So let's do some fun with this. I think you can see where I'm going with this. So key is equal to keyboard.getKey. We can now remove these, or let's just comment it out. So if key is equal to -1, left motor dot set velocity 0, right motor dot set velocity 0, else, or Python is elif, right? Key is equal to ord of let me just check. Yes, capitals. We want so now what I'm trying to do is WASD control. Okay, so now you want the right motor to move forward and the left motor to move forward but more slowly. So let's do left motor dot set velocity 5, right motor dot set velocity 10. Now let's move quickly. So S is going backwards, right? So -10, -10, AS, D. What is D? D is turning right, so 10 and 5. W is moving forward, right? So that is 10 and 10. So, and for good measure, let's print stop. So now let's give this a go. Let's see if this works or not. Okay, I've done something backwards, and this is a good lesson. Forward and backward is working correctly, but left and right have interchanged for some reason. Might be my interpretation of it. This happens very commonly, so let's just 10 and 5 and 5 and 10. Think it's about the clockwise thing, okay? Like the motors I have accidentally interchanged, so that's fine. So now we are able to get this thing to move at our command. So I'm, just to be clear, I'm actually typing out my command here. I'm just like, you know how you do it with a game. So this is
It is not shared.
what my screen share ended. How come?
Yeah. I don't know.
Weird. Anyway, sorry. Share screen. How come the chat window also ended right there? I could not see the chat. Yeah. Now is the screen share coming?
It's coming.
Yeah. No, okay, so can you see? Yeah, that's better. So can you see this? Yeah. So you've kind of got what I'm doing here. So just to recap, and of course we can pause the simulation. One thing to be careful is if you press this button and you haven't saved all the stuff you've done here, or in terms of getting the things, it'll delete all the extra things you have added. Okay, so be very careful. Every time before running, just save so that you don't lose anything. And this is cool-ish, I guess, but there's a lot more to explore, and but I think this is enough for a first shot. Any questions? Was it clear? So basically the hierarchy is you have a robot. In that you need to have a shape which will be the chassis. Whatever shape you do in here, you'll have an appearance and a geometry. That geometry you can choose from basic shapes, or you can import, which I'll show you later on. That's not really useful. So and appearance, of course, is appearance. This deft thing you put as a bounding object so that it will collide, and then you mess with the physics node. You can change the mass or density. This is in kilograms, this is in you can check in the documentation. I think it should be gram per cm cube or kg per meter cube. You will have to check up. And then once you do that, you have the hinge joints. Hinge joints will have the joint parameters, two devices, which will be the motor and the sensor. I have not shown you what to do with the sensor yet. That's next time. And we have the solid, which will be the actual thing the motor is connected to. Okay. So I think that's enough for the first session. You're absolutely clear about this, or like I can't see what your expression is right now, so I don't know what is the thing. Have you been able to follow? Have I gone too fast? Any feedback you have? I would just suggest you take the recording and you try it out yourself, okay? Just give it a shot once by yourself, and you should have a good idea. Yeah, you need to practice, definitely. And there's a lot of things to explore. Like, you can measure. Let's see if that works. I'll show you some examples now. Yeah. Aye. So yeah, that's it. I just was trying one thing, and if I go to the controller for this, it is there's all kinds of things you can do here. Of course, I took NumPy and Pandas because that's my life. Um, you have sensors, you can set the control PIDs, and you can change the amount of torque, enable the reading of what the torque is, and you can do all of that. And like, let's see what else is there here. So these plots here, I generated these in VBots itself. That simulation you saw of that backflip, this is the command which I gave in terms of position and the true value which it took. And like, you can also see the torques.
Bhaiya,
Yeah,
the plots aren't visible.
the plots aren't. What the hell? 1 second. What is visible and what isn't?
Your viewport screen is.
It's stuck on V. Oh shit! Sorry. I've been talking in thin air for the last. Ay. I'll just rewind 1 second. Sorry. This is what happens in a remote session. Yeah, it's very difficult to keep track. Screen share. So what I was saying was, you can read the. I've imported NumPy and Pandas and some other stuff. You can read the motor. You can set the PID. You can set the amount of torque which is allowed, and the velocity. You can read the torque values, and yeah, you can do other things. Oops really helps with managing all this. And if I do the analysis of it, I can get all this is data generated in VBots itself. So I know that there is something wrong here because this is way too jerky. And I can see what is actually happening in terms of the command and the actual thing. So I need to change my control logic so that it is not so jerky, and I need to mess with this a bit so that it is not like this. But yeah, this otherwise without the simulator I would not even know that this is not proper, because otherwise it would just be a guess, right? Let me zoom out. So the positions here correspond to the commands given to the front leg knee, like that, and the front leg hip torque you can get. So these are all the various features which are there. There are other things like you can simulate LiDAR and all kinds of other things are there. It's very interesting and it requires a lot of practice, but I hope this was a reasonably okay introduction to it. Any questions? No questions? Fine then. I think the session is over then. Just let me know if there's something which you would like me to cover next time. And since it's mainly who all are here, this is mainly 2020 and 2021, right? Here. So you can use the WhatsApp groups and ask me anything you want over there, okay? Or you can even shoot me a mail. Yeah, that's it. Thanks for coming, everyone. Bye.